Okay, so now we're going to look at a few different examples and use our TI-84 to figure out the range given a specific domain. Our first question says given f of x is equal to 2x minus 4 with a domain of -5 to 1, determine the range. So we go to our graphing calculator. We know that we have to go to y equals to type in our functions. So we'll put in 2x minus 4. Then we're going to do second graph to get to our table. So now we see here that we have x starting at 5, and we know that our domain from over here, x has to start at -5. So looking at our calculator, we have to go to find where x is -5. So we can see that the first range value that matches up with -5 is -14. And then we have to go up to 1, which is actually fortunately right here on our screen, and goes to -2. So that means that our range is -14 is less than or equal to y is less than or equal to -2. So all we had to do was find the values of our range, of our domain under the x, and then match up the y values with it. So now let's look at number 2. If g of x is equal to -x squared on the domain 2, 4, 6, 8 specifically, what is the range? So now in this question, instead of having a starting and an ending point for our domain, we have specific values of 2, 4, 6, 8. That means that our range will also only have at most 4 values as well. So let's go over here and we'll put in now our -x squared, and we will go to our table. And now I have to locate the values in the domain, which is my x, 2, 4, 6, and 8. So I'm going to scroll down. I'll get the 2 at the top, and actually I get all of them in this same screen. So when x is 2, y is -4, so that's the first value of my range. When x is 4, y is -16, so that's going to be my second value. When x is 6, y is -36, and then when x is 8, y is -64. So that means that my range is going to be -4, -16, -36, and -64. And we can just write it as a list of numbers, just like this, exactly as our domain looks, so we can just mirror that to write our range correctly. Number 3, h of x is graphed on the domain from 1 to 6. If h of x is equal to 2 to the x power, determine the range. Okay, so again, we have a continuous domain from 1 to 6. So we'll go over to our calculator, we'll put in our new function, which this time is 2 to the x, and we will go to our table. Now we're going from 1 to 6, so I have to scroll up a little bit here. So now I can see that the first value in my range is going to be 2. And then if I go down to where x is 6, I have a range value of 64. So that means if I come over here, I can see and write my interval that 2 is less than or equal to y is less than or 64 would be my range for this exponential function. Last one, number 4. Does h of x equal the absolute value of x minus 2 have a restricted domain or range, and explain? So in this case, we're not being given any restrictions. We have to determine if one already exists given the function. So let's go type in h of x into our y equals so that we can take a look at this. Now remember, to get your absolute value, you go to math, over to num, and hit number 1 for ABS. We're going to type in our x minus 2 and then use our over arrow to get out of the absolute value. So let's just, to start, go take a look, just hit graph, and let's look at the picture. Okay, so this is our absolute value function. Now, if we recall, the quadratic functions, which we just spoke about in the previous video, has a turning point. Well, our absolute values also have a turning point, which we can see right here, okay, because our graph is going in a negative direction, and then we turn to go in a positive direction. So when we have a turning point on a function, what that tells us is that we do in fact have a restricted domain and or range. We just have to figure out what it is. Now, if we compare this to our quadratic function and use what we know about quadratics, we know that the x's, or the domain, is infinite because we come from the negative side with no restriction, and then we go to positive infinity with no restriction. So our domain is going to be all real numbers. Okay, now the range is what we're going to have a restriction on. We need to look at the lowest value in our range, and then we need to look at the highest value. The lowest value in this range is going to be 0, which you can see here because we don't go below the x-axis, which means our smallest value in the range is going to be 0. And now, this graph is never going to end in the positive direction for the y's. It is going to infinity. So that means we have to make sure that we use just our less than symbol for infinity. And then we just put in our positive infinity. And this is our restricted range. And our explanation is going to be that it is restricted because it has a turning point. Okay, and that would be how to answer that question in full, and you are all set.